and welcome to the video. This is one video in a series of 4 which aims to show students exactly what a grade 9 question looks like in GCSE Maths. There is actually no such thing as a grade 9 topic, as some topics can be tested at grade 5, but then that same topic can also be tested at grade 9. It is actually based on how complex and how challenging a question is. That is what qualifies a question as a true grade 9 question. The simplest way to identify these questions is to look at the very last question in recent GCSE Maths papers. Here are some of those questions. Let's have a look at this grade 9 question, which involves knowledge of arithmetic sequences as well as creating and solving equations. This question was allocated 4 marks. It's a very brief question, but with the fact that it is a grade 9 question, it's going to be quite challenging to pick up all the marks available. Could you pause the video at this point and have a go at this question? Okay, welcome back to the video. If we have a look at the question, a few key words. We have 3 consecutive terms. We know it's an arithmetic sequence, we're told that. And we need to prove that the common difference of the sequence is 12. So we've got to prove the common difference. What we know about 3 consecutive terms in an arithmetic sequence is that the common difference between these 2 terms will be exactly the same as the common difference between these 2 terms. That's the nature of an arithmetic sequence. The common difference remains consistent. So here are my 3 terms. And if I take the second term and subtract the first term, I get 6x minus 21. I'm also going to do the same for taking the third term and subtracting the second term, which is what I've done here. This time I got 12x minus 54. And remember what I said before over here. The difference between those 2 terms, the common difference, has to be the same as the common difference between these 2 terms. So algebraically, this has to equal this. So because it's an arithmetic sequence, I know the common difference D must be the same. So the common difference here and the common difference here must be the same. So I can go ahead and make them equal to each other. Remember, you can always find the common difference by taking a term and subtracting the term before it, which is exactly what I've done here on 2 occasions. Now I've created an equation which I should be able to solve for x. So I subtract 6x from each side and I add 54 to each side. Then I'm just going to collect my terms. Then I'm going to go ahead and divide both sides by 6. 33 divided by 6 tells me that the value of x is 5.5. But of course, that's not the end of the question. I still need to show or prove that the common difference in the sequence is 12. But I do now know that x is 5.5. So I can take that 5.5, substitute it in here, substitute it here, and substitute it here to find out the 3 terms I was working with. So once I substitute 5.5 into my first term, I find out it was 34. My second term, 46. And my third consecutive term, once I substitute my x value of 5.5, is 58. So here are my 3 consecutive terms, 34, 46, 58. I've shown that using algebra. Just to finish off and ensure I pick up all 4 marks, I've wrote my 3 consecutive terms out and shown very obviously that their common difference is 12. Very well done if you would have picked up all 4 marks on that grade 9 question. In this question, you're asked about probability, which leads you into algebraic fractions, and then eventually solving quadratic equations. This question was allocated 5 marks. The start of the question should involve you drawing a probability tree and labeling the probabilities that the question tells you about. That's a good start for approaching this question. Could you pause the video at this point, read the question carefully, and have a go at this grade 9 question? Okay, welcome back to the video. Let's have a look at how I've approached the question. Okay, so what I've started with is I've taken the information from the question and I've placed it into a probability tree. So I'm told that 4 of the marbles are red and the rest of the marbles are yellow. So I don't know how many yellow there is or how many there is altogether. So I've just labeled the yellow marbles as N, which means on my first selection, when Antonia takes a random marble from the box and she does not replace it, there is 4 reds out of N plus 4. So that denominator N plus 4 is the 4 reds added to the N yellows. And that would be for selecting a red. The probability of selecting a yellow for Antonia is N out of N plus 4. My value of yellows out of my value of yellows and reds together. Then I've went ahead and completed the probability tree. Selecting a red given a red. So this is now for Sergio's selection. Probability of selecting a yellow given a red given a yellow, and a yellow given a yellow. So this is Sergio's selection given what Antonia selected in the first branches of the probability tree. And you can see I've labeled the fractions. If I just talk about this one here. If Antonia chose a red, that means there is 1 less red left to choose from, which is why I've reduced the 4 to a 3. And it also means I have 1 less for my denominator, because the amount of marbles I had altogether was N plus 4, but of course if 1 has been chosen and not replaced, that now becomes N plus 3. And that's the same for each branch. The denominator will always be N plus 3 because we have 1 less marble in the box, so that reduces our total denominator by 1. If, of course, Antonia chose a yellow, then that means the N value would have been reduced by 1, and the amount of reds in the box would have remained as 4. So whatever's happening on these second branches is dependent, is influenced about what has happened on the first selection. What we're actually interested in, though, is this bit here. We are told that the probability that Antonia and Sergio both take a yellow marble is 0.7. It's this that is vitally important. Because now we know that the probability of Antonia taking a yellow, which is N over N plus 4, multiplied by the probability of Sergio taking a yellow, which is N minus 1 over N plus 3, When I multiply those together, it's going to equal 0.7. So this bit here is what you're aiming for. This is the calculation that all this information is trying to get you to set up. This is what you're aiming for. Once we have that, we can now treat this calculation as some algebraic fractions and see if we can manipulate that to produce a quadratic equation. So this is how I start. The probability of Antonia selecting a yellow, the probability of Sergio selecting a yellow, given that Antonia already selected a yellow, equals 0.7. So I'm just going to go ahead and multiply those. N multiplied by n minus 1, so multiplying the numerators, and then n plus 4 multiplied by n plus 3, multiplying the denominators. So I've just tidied things up slightly. Now I'm just going to expand my denominator. So I've expanded my double brackets. Now I'm going to multiply both sides by n squared plus 7n plus 12. So I've taken this quadratic and multiplied each term by 0.7, which leaves me with this. Now I'm just going to tidy this up and make this equal to 0. So I have brought all of these terms onto the other side of the equal sign, which leaves me with 0.3n squared minus 5.9n minus 8.4 equaling 0. At this point, you may multiply by 10, so you're not dealing with decimals, but I've just left my quadratic equation as it is. Then I've taken my values of a being 0.3, b being minus 5.9, and c being minus 8.4, and I've substituted them into the quadratic formula. When you substitute the values of a, b, and c into the quadratic formula, like I've done here, you get your two answers, your two possible answers for n. N equals minus 4/3 and n equals 21. Because of the context of the question, we're dealing with an amount of marbles, minus 4/3 is not an appropriate answer. So I've just ignored that answer. The answer cannot be negative. It can also not be a fraction because we're dealing with whole marbles. So n equals 21 has to be my correct answer for the value of n. So n, remember from the start of my calculation, was how many yellow marbles I had. But the question wants us to work out how many marbles were originally in the box altogether. So I take my 21 and I add on the 4 reds which I started with, telling me that the amount of marbles I started with was actually 25. Very well done if you were able to pick up all 5 marks on this challenging question. Taking the information, producing the probability tree. From the probability tree, you're able to create a calculation. Then you can follow through with a bit of algebra by simplifying the algebraic fractions, leading to a quadratic equation. And from that point, I've used the quadratic formula to find the value of n, which allows me to find my final answer. Very well done if you completed that question. Thank you for watching, and remember, practicing past paper questions is easily the best way to be successful in GCSE Maths.